Alright, today we're talking about creating equations. So when we are creating equations, we're going to be starting with our answer and then working backwards. So for this example, it says if we know that x equals 4, well then 2x equals 8, because what we did is we doubled our x's, so we double our 4. So if we have two x's, so if we have an x equals 4 and another x equals 4, we have two x's and it's going to equal 8. So we're doubling our x's, so we double our number. So we multiplied both sides by 2. Well, then we can also say, well, I can subtract 4 from that. So if I did a minus 4 here, I'm going to do 8 minus 4, which will give me a 4. So as long as we are using our properties, that was our subtraction property of equality, where we subtracted 4 from the left side, and then from the right side, our equation will still work out correct. So then we can also check that our equation is correct by, one, we can plug our answer. So if we have x equals 4, we can plug in our 4 and then figure out, and it should give us a correct answer. So you plug in the 4, 2 times 4 is 8, 8 minus 4 is 4. It's correct. Or we can solve our equation, add 4 to both sides, divide by 2, and x is equal to 4. So there's two ways to check it. So when we're creating our equations, all we're doing is working backwards, starting with the answer and developing our problem backwards, but making sure whatever we do to one side, we have to do to the other side. Now, Haley and Ashley were creating an equation. Well, who's correct? Pause it for a minute, try to figure out by yourself, write an explanation, and then I'm going to go over it. So hopefully you paused it. Hopefully you came up with your explanation. Well, now let's see what Haley did. So Haley says a equals 6. She did negative 4a equals negative 24. So it looks like she multiplied both sides by negative 4. So times negative 4. And then minus 8. And then she subtracted 8. So her equation is correct. The way we could check hers is we can plug 6 in. So we can do negative 4 times 6 minus 8 equals negative 32. Well, that's negative 24 minus 8 equals negative 32. Negative 32 equals negative 32. Correct. Or we could have solved this one and said plus 8 plus 8. Negative 4a equals negative 24. Once again, see how this step is related to that step. And then we divide by negative 4. Divide by negative 4. A equals 6. And that is our very first step. And then we look at Ashley. Well, she says a equals 6. A equals 6, and then a plus 4 equals 10. Well, a added 4 to this side, we added 4 to this side. 3a plus 4 equals 30. Well, we multiplied a by 3, so we multiplied 10 by 3. So it looks like her equation is also correct. But she forgot to do one thing, which is a very common mistake. Now, when she multiplied a, she did not multiply this 4. So if she wants to multiply, she has to multiply everything on that side of the equation to give her a correct answer. So she has to take this whole thing, a plus 4, and multiply it by 3, and then do multiplying by 3. So the answer, who was right? Well, Haley was correct. Haley was correct. And hopefully my explanation, I just explained to you why, because Ashley didn't multiply her entire equation by 3. She only multiplied the a. And Haley did all of her steps right, and we checked Haley's to show that it was correct. So, how could we show equations with combining like terms? Well, we know that combining like terms would be something like 2x plus 3x. So the way that we want to show that is that, let's say that we start with a equals 10. Well, if I want to show, or not a, let me erase that. Let's start with x equals 10. Well, if I want to show this combining like term of 2x plus 3x, well, that is really 5x. So that's saying I need 5 of these x's, so I'm going to multiply this side by 5 and multiply this side by 5. So what I know is I have 5x is equal to 50. Well, I'm going to break my 5x into 2x plus 3x. So I'll have 2x plus 3x now equals 50. I didn't do anything. I just changed 5x and broke it apart. So I didn't add or subtract anything to that side, so that's why it's still balanced. So I'm just saying, well, I'm going to break my 5x and say it's 2x and it's 3x. So that's one way that we can show combining like terms. How could we show equations with the distributive property? Well, once again, that's kind of what Ashley should have did in her example. So if we take a look and we have a equals 3. Well, we can add a number to both sides. So if I add 2 to both sides, a plus 2 equals 3 plus 2, which is going to give me 5. Well, now I need to take this entire side and multiply by a number. So we can multiply it by 4. So now I have the distributive property. So now we have 4 times a plus 2, and then we have equals 4 times 3 plus 2. Well, we know that 3 plus 2 is 5, and 4 times 5 is 20, so we'd have this equation 4 times a plus 2 is equal to 20. And now, how could we show an equation with variables on both sides? Well, what we would have to start off with is we have to start off with our answer. Well, what do we want to know? Well, we can say that b equals 6. Now we can add b's to both sides. So if I want to say b plus 2b is equal to 6 plus 2b. So I added that b to both sides. So that's how we can show an equation where there's variables on both sides. So now we're gonna make two equations up real quick. So we're just gonna go over here and flip your paper over so we can create these two equations. So number one, we will start with a equals 3. Now I want to do this one. I want to have the distributive property and variables on both sides. So to get the distributive property, I might add 4 to both sides. So I'm going to do a plus 4 equals 3 plus 4. Well, I know that 3 plus 4 is going to give me 7. So we know that a plus 4 equals 7. Now, for the distributive property, I'm going to multiply both sides by 3. So if I multiply this side by 3, now I have to multiply this side by 3. So now I have my new equation, which is 3a plus 4 equals 21. So now I have a two-step equation to figure this answer out. I have 3a plus 4 equals 21. Actually, I forgot my parentheses. 3 times a plus 4 equals 21. So now I have a distributive property in order to solve this. So there's one example. If I want to have one with even combining like terms and variables on both sides, once again, we need to start with, let's say b equals negative 6. So if b is equal to negative 6, I can say b plus 4 equals negative 6 plus 4. Added 4 to both sides. So now if b plus 4 is equal to this is going to give me negative 2. And now let's say if I want to add a variable on both sides. So b plus 4 plus 5b is equal to negative 2 plus 5b. Now I might want to leave this out so I have combining like terms. So I have b plus a 5b. And then we can make this even one step farther and say b plus 4 plus 5b plus 3. And then negative 2 plus 5b plus 3. Once again, all I did was add 3 to both sides. Now we have combining like terms on the left side, combining like terms on the right side, and variables on both sides. So that's how we can get these two-step equations and multi-step equations. We can get combining like terms, we can get variables on both sides, we can get the distributive property. Make sure at the distributive property you have to put the parentheses around them. And that is how we create these equations starting with an answer.